continuing along with our explorations of seeing if we can improve the model fit. In this case, here I have exercise 2, where I say that seasons is a categorical variable, which means an ANOVA is more appropriate than a regression. So instead, I suggest to use temperature in the design matrix and rerun the regression. Okay, and then I say, let's go back to the original data set that includes the no rainfall days and the rainfall days. So basically, not selecting data according to rainfall, and just putting the temperature, which is a continuous measure, into the ANOVA. Okay, and then, the model fitting still isn't perfect. It's qualitatively a little bit weird. There's a lot of clustering down here. It's hard to interpret these negative predicted byte counts, but that just happens with regression. And yeah, this looks a little bit more like a nonlinear trend than a linear fit. But anyway, I think you can see that both the qualitative and the quantitative measures of the model fit to the data is definitely better compared to what we've done so far. Okay, so again, the goal is fairly straightforward. We just want to use temperature in the model as a continuous predictor of bike rentals. So let me scroll back up quickly to exercise 1 just to show you the code. So here I create the design matrix using rainfall and seasons. That's what we did also earlier in the text. And now, if for exercise 2, we are going to use rainfall and temperature. So same overall procedure, same idea, same concept, same data set. Almost everything is the same. We're just running a different model with 1 out of 3 predictors being different, right? So we have the intercept and rainfall, those are the same. And now I'm just using temperature. Okay, so then otherwise this code is all the same. Here we are getting the predicted data values, computing the model fit to the data as the squared correlation coefficient, and then generating a plot. And as you saw in the book figure, the fit is certainly a lot better. 0.3 is actually pretty decent for a model. If we were working with these in a real application, if this were for a real bike share company, or maybe for research purposes, if we were going to publish this, we still want to continue working with this and see if we can improve the overall fit to the model. Maybe we need a nonlinear model instead of a simple linear model. But again, my main goal here is to illustrate to you how the math that you have learned over the previous few chapters, including the inverse, the left inverse, maps onto real world statistics, exactly how statistics are done in practice.